Alright guys, so this is the continuation. This is going to be, I don't know, I just want to try and keep the videos to 10 minutes approximately, plus YouTube only lets me upload to 15 minutes, so. Alright, so 9.3, this is from our first part of chapter 9, and this is finding the points of discontinuity, excuse me, and also describing any vertical asymptotes and holes. Right, so we have 1 through 8, so number 9 is not even an option, right? That was the one that you had to use the quadratic formula, so no worries there. So let's pick one. Let's go ahead and take number 5. 5 looks a little bit overwhelming, yeah? All right, so looking for points of discontinuity. Now, it's good to identify what you're looking for so that you don't end up doing extra work. Because we're looking just for points of discontinuity, we don't care about the numerator, right? So I'm not going to put an X there because then it's going to look like a variable. We just don't care, right? So you don't even have to worry about that at all. Now I am going to write it down there just because I'm a math teacher and that's what I do. So we have y equals x squared plus 5x plus 6 all over x squared plus 6x plus 9. Okay, so again, we don't care about this numerator because we're just looking for points of discontinuity. Points of discontinuity are located in the denominator. So we need to factor that denominator, and we have x squared plus 5x plus 6 all over, okay, values of, or factors of 9 that will give us a sum or difference, in this case a sum of 6, and that would be 3. So then you have x plus 3 times x plus 3, right? Okay, and now to find the points of discontinuity, you set your denominator, whatever is in the denominator, equal to 0, using that zero product property. So you would have x plus 3 equals 0, so then you subtract 3, x is negative 3, and that's the same here. So the points of discontinuity are just going to be, for this one, x is negative 3. Okay, and that's it. All right, so now let's take a look at the 10 through 17. Okay, so 18 is not going to be one of the problems, so no worries there. Again, that one was kind of a bit overwhelming if I'm not mistaken. So one of these describe the vertical asymptotes and holes for the graph of each rational function. All right, so let's take a look at jeepers. I don't know. Let's do, oh no, 14 or 17. Let's go ahead and go with 14. Okay, so 14 we have y equals x squared minus 4 all over x plus 2. All right, well, x squared minus 4 is a difference of squares. So then this gives you x minus 2, x plus 2 all over x plus 2. Well, if you have a common factor from the numerator and denominator, that is going to create a hole. Okay, so then we have a hole at x is negative 2. Okay, vertical asymptotes occur when you only have the expression in the denominator. So looking over here at like 13, this x minus 2, and x minus 2 in the numerator, so this would create a hole because you have an expression in the numerator and the denominator, and then this one's going to create a vertical asymptote because it is only in the denominator and it's not the same as anything else, right? Okay, so this one would give you a hole at x is 2, so I need to put a hole there, and it's going to give you the vertical asymptote at x is negative 1. Okay, hopefully that's enough of a review on that one. But remember, if there is a hole and vertical asymptote at the same place, you cannot have a hole where you have a vertical asymptote. A hole is just a jump in the graph, whereas the vertical asymptote is a complete break in the graph. So the complete break takes precedent over just the hole. Okay, next section, 9.4, so the new stuff. We have 1 through 6, one question from here. So simplify the rational expression, state any restrictions on your variable. So let's take a look at number 6. So you have x squared plus 8x plus 16 over x squared minus 2x minus 24. So x squared plus 8x plus 16 all over x squared minus 2x minus 24. All right, so I'm looking at factors of 16. That would give me 8, and in this case, that would be 4 times 4. Factors of negative 24, that would give me a negative 2, about negative 6 and positive 4. Okay, so then that gives me x plus 4 all over x minus 6 and x plus 4. Okay, so remember, it's in your best interest to state restrictions right away before you cancel, because a restriction is anytime your expression could equal 0, whether at the very beginning before you simplify or at the end after you've simplified. So we have x minus 6, so we're going to have x can't equal 6, and then we're going to have x can't equal 4. Okay, so you're going to set both of those equal to 0 and solve, and that should be negative 4. My apologies. Oops. Okay, so that should be negative 4, not positive 4, because when you set that equal to 0, you have to subtract 4. All right, and now that we have our restrictions, now we can cancel out like expressions, and you're left with x plus 4 over x minus 6. So you have your simplified rational function expression, and you also have your restrictions. 7 through 12, there are 2 questions from here, and that is multiplying and then stating any restrictions on your variable. So let's take a look at number number 11. Okay, so x squared minus 4, that is a difference of squares. So that's going to be x minus 2, x plus 2. All over, that's another difference of squares. X minus 1, x plus 1. Times, we have just the expression x plus 1, all over x squared plus 2x. They have an x in common, so I'm going to factor out that x, leaving us with x plus 2. All right, so now looking at restrictions, right? So we have x minus 1 equals 0, so then that's x can't equal 1. X plus 1 equals 0, so x can't equal negative 1. X can't equal 0, and x can't equal negative 2. All right, so those are the restrictions. Now we're going to multiply, canceling any like expression from the numerator to denominator. So we have an x minus 2 here, but we do not have an x minus 2 in the denominator. We have an x plus 2 in the numerator, and we have an x plus 2 in the denominator. We have an x plus 1 in the numerator, and we also have an x plus 1 in the denominator. So now that leaves us with x minus 2 in the numerator, all over x times the expression x minus 1 in the denominator. Okay, so then that's our answer, and you can either leave it like this, or you can then do the x doesn't equal negative 2, negative 1, 0, 1. All right, 13 through 18, we have 2 from here, and this is the divide, and so we're going to end up using multiplication. The leave it, change it, flip it, so that it's basically using multiplication. Let's go ahead and take a look at, let's take a look at 18. All right, so you have y squared minus 5y plus 6 over y cubed divided by y squared plus 3y minus 10. Okay, so y squared minus 5y plus 6, to get negative 5, when you add them together out of a plus 6, you're going to have negative 3 and negative 2. So we have y minus 3 times y minus 2 all over y cubed divided by y squared plus 3y minus 10. That's going to be negative 5 and positive 2. And then that's all over 4y squared. Okay, so now keep in mind that when you are dividing, we have to leave it. So this is a possible 0, and then we have to flip it. Well, this is a possible 0 as it stands, and then when we flip it, this is a possible 0, so a possible restriction, I should say. So we have to take all of those into consideration. So now when we do the restrictions, we are going to have y cubed equals 0. We're going to have 4y squared equals 0. You're going to have y minus 5 equals 0. And you'll have y plus 2 equals 0. Okay, well, y cubed equals 0. You took the cubic root of both sides. So then y can't equal 0. Divide both sides by 4. That leaves you 0. Take the square root. It's still 0. Add 5, so y can't equal 5. Subtract 2, so y can't equal negative 2. So those are the restrictions. And then we're going to leave it. So leave the first term as it is. Change that to multiplication, and then flip it. All over y minus 5, y plus 2. Okay, so if we have common expressions from the numerator to denominator, we are going to cancel them out. So there's a y minus 3, y minus 2, y minus 5, y plus 2, and I'm going to double check and make sure I didn't make a mistake, and I did. All right, so, and that's what happens, because like something should cancel, right? So this should have been a positive 5, and this should have been a negative 2, which then also changes this, because that should be a negative 5, because that would be positive 5, and this would be negative, so that makes that positive 2, right? So change that to positive, change that to negative. Right, so I didn't do that on purpose, obviously, but at the same time, it's good to see it because it's an easy fix because I showed my work, okay? So same thing for you. Show your steps and go back. Something should cancel. If it doesn't, then just double check. And then sometimes maybe it doesn't, but I did want to make sure. Right, so then the y minus 2 expressions are going to cancel out. And then we have y squared and y cubed. Well, that means I have y times y, and I have y times y times y. So the y squared is going to cancel from the numerator. We're going to subtract 2 from this y cubed, or 2 from the exponent, leaving us with just a y. So then my final answer is 4 times y minus 3 all over y times y plus 5. And then we have our restriction, y cannot equal 0, negative 5, and 2. All right, that's a wrap for 9.3 and 9.4. I'm going to go ahead and stop right now, and I'll resume in another video.